Welcome to this session of Shadow the Science, testing the taxonomy of Neptunian Trojans in the near infrared with Keck Observatory. My name is Eureka Marshall, and I'm very pleased to serve as the Shadow the Scientist Programs Manager. And this evening, you are in for a treat. I'm live here at the Mauna Kea Visitor Information Station, just below the 10,000-foot level here, the majestic Mauna Kea. And we have some live audience members here. Yes, thank you for joining. Yes, and so tonight, this session is just for those who are here. So this is just for you. Yes, and you are in for a stellar experience with an amazing team, starting with Bryce Bolin from Eureka Scientific, Laura May Abron, Griffith Observatory, and Matthew Belyakov of Caltech. Now, they are already connected virtually on the Keck Zoom, and they'll be controlling the telescope, working with the amazing Keck team remotely to do their observations. So I'm going to stop sharing now so that we can go back over to Bryce to get us started, and we can meet the rest of the team. Bryce, welcome.
Hi, my name is Bryce Bolin. I'm an astronomer studying the solar system, outer solar system objects. So right now, we are in the process of setting up the telescope. We were closed for the last hour due to thick clouds, but we are in the process of focusing and getting going here. I was just talking with the observer here who is at the summit at Keck I. And are y'all able to see my screen here?
Oh, Bryce, I took over your screen share when I did my quick little intro, so please reshare your screen.
Oh, okay. Hold on one second. Yeah, sorry about that. I know we're supposed to be doing intros.
No, all good. No worries. That was totally me.
Yes. So yeah, right now the observer at the summit is helping us out by focusing the telescope and checking the pointing. So she is targeting the star right now. One moment. Julie, do you need me to change the filter from dark to J or?
So there's an astronomer at the summit at Keck who is controlling the telescope, and then there's several.
Okay, fantastic.
Also, in case there are any issues, talking to the support astronomer who's at the summit.
Yeah, sorry about that. I just had to check in with the observer to make sure that everything is ready to go for what she needs to do for the focusing.
You know, I thought that I could just do a mirror because the mask is fully open.
Yes.
The mirror is warning me that it's going to move the CSU.
CSU. So I see the grading is in place right now. Do we need to take the grading out and put the mirror in?
I don't really know. Josh is not there anymore?
Yeah, he's not here.
The CSU is all the bars.
Yes.
Assuming you don't want it moved?
We want the mask to be open. Is it not? It says it's open, so is it not open?
Well, I thought that would then be fine to do Mira, but Mira is telling me that it's going to move it. So anyway, I'll call Josh.
Okay.
If you want it moved, that maybe we're supposed to do an autofocus instead.
Yeah. So I don't know. The mask is so maybe I need to click on execute mask. Maybe it didn't actually open.
Oh, it opened it. I'll I'll call Josh.
Okay.
Bryce, while we're waiting for her to connect with Josh, could you give us a quick intro, and then let's hear from Laura May and Matthew, if possible?
Yes, so tonight we are observing on the Keck telescope to study asteroids that are out by the orbit of Neptune, called Neptunian Trojans. These are objects that we think are very, very old. They've been there since the dawn of the solar system. And by studying them, we can learn more about the birth environment of the planets and the asteroids. We're going to be using a near-infrared camera to do that, called MOSFIRE on Keck. It is the most sensitive near-infrared camera on the planet. This camera can give us diagnostic information about the composition as well as the type of objects that we are looking at. Laura May or Matthew, would you like to go next?
Sure. Hello. My name is Laura May Abron. I have been doing some observations with Bryce for just about a year now. Sometimes we go to the summit on Mauna Kea in Hawaii, and other times we can do this remotely. So we're actually all three. I think two of us are in the same country. I don't know where Matthew is right now. I don't know if he's still where he was last week.
I'm actually in Cahill, so
Oh,
back-
okay.
yeah.
Okay, so what two of us are in the same city, but not in the same room. And Bryce is still in France, I think. So usually when I assist on this, I'm gonna do some logging. This is really important so that we can figure out when we are taking basically our images, we want to know what filters we're using and which exposures, and we want to track the numbers carefully so that we know when we're going back through them and that we actually want to work with those images, we can figure out what is what object, because otherwise it's just a bunch of blobs. And so we need to be able to assign some numbers and things like that to the blobs so that we can then sort them. So yeah, so if fortunately, I think it was cloudy earlier, but now we are going to be able to get some observations and log things and all sorts of things. Matthew, hand it over to you.
Hey, so I'm Matthew Belyakov, graduate student at Caltech, and Bryce, Laura May, and I have been sort of working for a year now towards getting these Neptune Trojans characterized. And I'm sort of I've been helping Bryce figure out sort of what's the best way to go about these observations, because these are really, really faint targets, even for one of the biggest telescopes in the world with this excellent camera. These are difficult targets. We're getting, if the conditions are good, three a night. If the conditions are bad, 2, 1, none. And there are other Trojans in the solar system. There are these Jupiter Trojans, and they're much closer, much easier to characterize. And this is sort of pushing these frontiers forward. And we're really trying to poke at the finer details of their composition. And this half night, along with our other half nights, hopefully can start to fill in and get us some, bigger number statistics on what's happening with this population. So yeah, hopefully the weather starts to clear up, though, looking at the humidity, if anything, it's going the other way. But yeah.
It is, we are always dependent on the weather. If you do
Oh, yeah.
observational, this is, and even if, if you're an amateur astronomer and you have some scopes, I do some things with the Los Angeles Astronomical Society, and that's just kind of how it is. You wait and you hope that clouds will clear, and Mauna Kea is one of the places in the world with the most incredible weather, which is why we have telescopes there, but we're still dependent on weather and humidity and things like that. So it's just like being a person out in a field with a telescope, basically.
Yeah. and the received wisdom is, Keck is a 10-meter telescope. So if the weather is bad at the start of the night, you wait 10 hours, right? The meter class of the telescope is the number of hours you wait until you give up on the weather. So even if it's, raining, snowing, they have to close the dome, you just sit and wait for the 10 hours because this time is valuable, one of a kind, so you cannot let it go to waste. Every photon on the sky, it's got to be collected. So.
Yeah, a lot of people would like time on these telescopes. So that is, people fight for time on these. And so even if it's cloudy and you're like, yeah, whatever, you're like, nope. As Matthew said, you wait and you see if you can maybe get a little bit of no clouds.
Yeah, the kind of saying is this: the size of the telescope is the o'clock that you wait to. So if you're on a 1-meter telescope, you have to wait till 1 a.m. if the weather's bad. It's a 3-meter telescope, you got to wait till 3 a.m. But if you're on a 10-meter telescope, well, you got to stay up to 10 a.m. That's just the way it goes.
Yeah,
Basically all night.
we love it.
And so going with that, what happens, just for the benefit of our audience here, what happens if you aren't able to open for some reason? Are you able to get that time back, or do you have to repropose?
To repropose. So, you get unlucky, It's just the way the weather is. I mean, it's shared risk. You apply for time, it's going to be the winter. Weather is finicky. Yeah, you're getting maybe more time in a night. Night's slightly longer. Different for, if it's a Palomar further up in the northern hemisphere, you benefit a bit more. Mauna Kea, it doesn't matter that much. But the point is, yeah, you lose the time and that's it.
Sorry to interrupt y'all, but
Do you want to go to the same target at the 620 now?
So we might do a fun thing first, if that's all right. We were thinking of actually going to look at Uranus. Is that all right with you?
Absolutely.
Last time
Lots
we did
of
this,
claps here.
the
Lots of claps
observer,
here.
Uranus, the planet Uranus.
Yeah.
Here it is.
So last time we did this, it was like automatically in the system. I didn't have to put it in the target list or anything, but I could do that if you need it. And so our seeing right now, the full tap max is 1 arcsecond. Laura May, could you record that
Yep.
in that in our
Yep.
records? Or
Yep. You said 1 arcsecond?
yes.
Cool.
So we're gonna try to do something fun real quick at the start, which is to show the Uranian system.
You have on your radio, please.
I'm sorry, Julie. What was that?
On my radio, Uranus.
Okay, thank you. So Julie is slewing the telescope for us right now. Let's see. Let me make sure. Okay,
Make sure to go to K-band,
okay.
Bryce.
Yeah, whenever we slew the telescope, we have to put it in this quick dark mode right here because this is a near infrared telescope, so it actually doesn't have a shutter. Because the shutter would be too hot So we have to leave the shutter open. Basically, it has a hatch, and once we open the hatch, the instrument is exposed. So while slewing, we have to put in a dark filter so that we don't expose the array any bright sources, which could cause persistence or even damage it. This telescoping camera is so sensitive that looking at a source that is too bright could actually cause negative effects to it, as well as to the performance of the instrument. So for safety, we have to put a dark filter in front of it to block that off. So right now we're looking at, we're going to look at the Uranian system, planet Uranus. Or I think we'll be able to see the rings, hopefully, and maybe some of the satellites. So we will see pretty soon. I'm going to go ahead and get the exposures set up. So we will, what did we do last time for this? Let's see.
Definitely do K-band for the imaging.
Yeah, K-band's the way to go. Let's see here. Let's see. So we did 5-second exposures. No, 6-second exposures. Oh, we did six coads. We did 5 coads. So I mean that's like a 30-second exposure effectively. We did that times 5. So yeah, I think we'll do that. We'll do 6-second integrations here.
How many
Connection
coads?
is my VNC is acting slow here.
I think 6 coads.
Matthew, do you have the VNC pulled up on your end?
Yeah, I do.
Matthew?
Yeah, yeah.
Do you want to in exposure control put object Uranus integration time 6 seconds and 5 coads?
Yeah.
We're in K-band, right?
Yeah, so the connection in K-band. So the connection I have here is better than the previous my previous place, but having everything going all at once, the 2 zooms and everything, and screen share and VNC is overloading it. So it's helpful to have backup here. So hold on, I think we're
I'm
not,
moving filters
I
to
don't know if we're
K-band.
there yet. Are we? Okay. Well, wait. Let me. Are we okay to take exposures now, Julie?
So I guess it's pretty well centered, huh?
Yeah, it looks pretty good.
Yeah, I think I'm gonna just not guide it.
Okay. So is it all right if we start taking integrations?
Yep.
Okay. So yeah, Matthew, it's still acting a little slow. So what I need you to do is in this MOSFIRE server window.
Yeah.
Can you type in box 5, all one word, BOX 5?
Yep.
All lowercase, all one word.
Yep. Already done.
Okay. And okay, so it's going. Yeah, it's not updating on my side, so things might be stuck. Yeah, it looks like my VNC is stuck. Oh, I can see some things changing here. Yeah, this might be overloading my connection. I'm gonna turn off my video to see if that helps. Matthew, is does the computer you're using have the Zoom on it? Do you want to try logging on Zoom so you can show the audience the
So unfortunately, I don't think so, no. I'm
Okay,
on
well, let's just see if
I'm
it
on the
loads up.
Caltech
I have the
computer.
Okay. All right. Well, looks like something's happening here. My
Yeah, we
connection
got
is
the
pretty
first
bad, but
exposure, I think.
yeah, I don't have a planet there though. Well, we
Yeah.
have to subtract them.
Why are we seeing the
So I see it in the guide.
edge there? Grading. Okay, no. I forget, does MOSFIRE always have this pattern of the sort of
Yeah, so when you take individual images, you see the kind of, boxy thing going on there. So hold on, let's see. Have we gotten the second image yet?
yeah, it should have come through.
Because then we can difference them. Let me ask Julie real quick. Julia, do we have Uranus centered in the MOSFIRE field of view, or is it because I could see it in the guider, but the guide window, I
Yeah,
think
because Guider is
that's
offset,
Uranus,
right?
right? I can see the moons. Isn't the guider off from the
You
instrument?
know what? It changed the pointing origin.
Okay. So do you
Yeah,
want?
I probably need to change the pointing origin. I'm sorry.
Oh, no worries. So Matthew, can you? Okay. So Julie's gonna put the planet into the instruments field of
Okay.
view. Matthew, do you want to Control C the script? Just keep hitting Control C until it stops.
Okay, it's good now.
Yeah, we'll do another box 5.
Okay, well,
Just let it go.
let's wait for, I mean, it's gonna take one bad exposure and then the last two dithers are gonna be fine, so whatever.
Looks like we've got moons now, no?
Wait, let's see.
Or are those, wait.
No, those are just, there we, that's
Yeah, no,
it
those.
right there. So I prefer,
There it is. Yeah, there it is. Are y'all looking at the auto display window? So you can see Uranus.
oh,
Oh, the color's
sorry.
different
Let
now.
me try to get it. Yeah, you need to subtract it, but
Yeah. So yeah, you can see it. So yeah. And there it is. Yeah, wow, that's the Uranian system.
yeah. Oop.
Yay.
Okay, wow.
There we go.
It might help if you go to scale and you do min max.
Oh, so that's the delta. Let's wait for the next one to come in.
Look at that.
Well,
We've got rings now.
Matthew, if you hit scale, click the scale tab.
Yeah, min max.
No, because that does something weird. Just
Okay.
click the actual tab on like the window here. Let me see if I can do it. And now you gotta play with the stretch a little bit. There you go. Now you can see it there.
Beautiful.
So oh, what happened? Now it's black again.
Let me.
Yeah, you can see there's like some brightness variations in the ring plane. Yeah.
Oh yeah.
Did we get a second exposure on this yet?
So okay, let me take care of that. Let me try. Okay, yeah, I'm doing another box 5 and then we should move to our targets.
Yeah, right. But I mean, do you know which moons these are? Off the top of your head, you've been studying the Uranian system for a while now, right?
Yeah, so we actually see I think we see even some of the smaller ones here. This is the one I got the spectrum of the other day.
Wow.
Yeah. So I believe that one is Portia, the named after the wife of Julius Caesar, because all of these are generally Shakespearean characters.
Yeah.
And this one right here, I believe, is probably Puck. Then we have, oh no, this is probably Puck. Then this is Miranda, Ariel, Umbriel, Titania, Oberon from Midsummer's Night Dream. Actually, don't know if this one is a moon or just a background star.
Yeah, that's what I was
hard,
wondering earlier.
it's hard to tell, these things.
Do you want? We just got the second exposure. Do you want to take the
Yeah.
do the difference?
Oh,
Well, it didn't really dither. So maybe
yeah, it didn't dither on this one. Well, yeah, we'll wait.
Okay, yeah, we have to set the dither parameters actually. Yeah. So good.
Exposure.
Yeah, so it's not going to do dithers properly, but
Okay. Well, good that we're testing it on this.
yeah. So I need this. Yeah. So let me set the dither. I'm going to control C this if I can, if that's all right.
Just set the dither pattern. Let it take the exposure. Don't waste the time. Might as well just take it.
There's no way to.
There's no
change
way.
it.
Okay, then yeah.
Yeah. So we have to click abort after frame, and then control C. Let's see if I can do that. Don't use that. Don't use that menu for the. Okay, now I can actually do stuff. So okay, so I have to put in the command now. Hold on, I'm gonna stop sharing my screen right now for really briefly. Because I need to look up the command. There we go. Okay. All right, I can share screen again. 1 second. Okay. So here's my Keck MOSFIRE cheat sheet. So the dither command. Let's see, this window is hiding a little bit. So now my connection's good enough that I can type stuff. Node. Oops. Modify -S. MOSFIRE. Node. All right. Okay. So I think that is
10 pixels or 10 arc seconds for the dither.
So it's half a square. It's half a square of it. So it's 20. It's a total 20 arc second distance.
Okay, arcs.
So let's just let's see. So I think we're done with the box. Like there's no script running right now. So I'm gonna do box 5. We'll just take like 2 exposures just so people can see the difference.
Yeah.
The difference. So like basically this is a near infrared instrument and it's so hot that the instrument and sky background is so hot that we have to move the camera around and take the difference between the two in order to remove the hot sky background. When you're using a visible camera, you don't really have that issue. The sky isn't as hot, but in the infrared, the sky is hot enough that it actually causes there to be a substantial increase in the background brightness, the background sky brightness. It's from the Earth's water atmosphere. So we just took we have to wait for the 2 exposures to complete before we can do any sort of differencing. So in infrared astronomy, you get around this issue by doing between 4 and 5 dithers, sometimes more. You can do up to 10, where you kind of jiggle the camera around. We call that dithering. And in this case, we do it. We dither by with a distance of 10 arc seconds. So the telescope takes an image in the center position, and after the image is done, it moves the camera 10 arc seconds into another direction, and then takes the image. So that way, these are going to be distant enough from each other, such that when you subtract the two images together, you remove the sky component from the image. So I think we can do the difference now. You want to try that, Matthew? Press tab, and when you
Yeah, there we go.
this window, and it will. Yes. So there you go. So you have like a kind of a negative and a positive. So let's see. Can we put it on min max mode? I'll just go ahead and click it. Matthew, do you want to play with the stretch to bring it out?
Yeah, there we go.
Yeah. So that's so the result is that the white is the
Exposure.
positive image, and the difference between the two creates negative value pixels, which show up as black after images. So I'm going to go ahead and actually we'll just let this script run, so it just to complete the box 5.
Don't bother. Just kill the next one.
All right. So let's see. I have to go here. Board after frame. I'm going to do Control C, Control C, Control C, Control C. Yeah, so you have to press Control C for every step in the script. Okay. So yes, there.
Complete.
There is the Uranian system. I'm going to tell the operator real quick to I'm going to highlight our next target and tell the operator that we're slewing. So give me one moment. Hi, Julie. I'm going to highlight the next target. Is that all right if we slew to that slew soon? Okay. So we're going to target this VV165 object next. All right, so I'm going to highlight that in the the time is it's 6:36 UTC. So I'm going to highlight the ephemeris for that time.
BB167, you said? No?
Sorry,
16.
one. Julie, I've highlighted the target. I've highlighted the target. Please slew when you are ready. Oh yeah, I need to put in quick dark.
Hey, can you put the dark?
Yeah, 1 second. Yeah. Quick, I am it's moving right now. So I'm gonna fix this window. It's a little wonky. There we go. I'm gonna put this over here.
Well, you only got K-band for Uranus, correct?
Yeah.
That is correct. And sorry, Laura made the next target is V as in Victor, VV165. So V as in Victor, V as in Victor, 165.
Awesome, thank you.
Okay, so the reason why I have this window like this is because it's hard to scroll up with this window. You have to have a mouse with a middle click, and the Mac, unfortunately, does not. Steve Jobs, in his wisdom, not give Mac a middle click functionality, and so it's impossible to scroll up this window. So I have it in this large aspect ratio here, so we can see the execution of the script when we are completing it.
So Bryce, this target is what magnitude?
It's 23.6, I think. So it's tough. All of our targets are about that.
But this one is
so
less tough than some of the other ones.
let's see. So the Minor Planet Center is predicting that I had this going, I closed it. Let's see here. Oh, internet, it's either the Minor Planet Center or my internet connection is running a little slowly here, but that's okay.
Are we starting with the wideband or?
Yeah, we're gonna start with wideband, but we can't change filter or
I know.
anything until.
We should just set the integration time.
Yep, so that's 30 seconds integration time, 6 coads.
Okay, 6 coads.
So yes, doing the test of Uranus is nice, so we can make sure the dither pattern is working well. And plus it's fun to see. I can see there might be some persistence here. Let's see. There might be a little bit of persistence, but we can fix that. Do not worry. So Matthew, maybe let's take a test exposure. We won't run the box 5, but
Yeah.
maybe let's take instead of doing 6 coads, we'll just do 1 30-second exposure. Don't worry, I have my internet connection is stabilized now. I guess the neighbors stopped watching Netflix or something. It's actually working pretty well now. Yeah, streaming. Okay. All right. Okay. Here we are. It's up here. So we're going to do a test exposure. Just to make sure we don't see the permanent imprint of Uranus. So in K-band, Uranus is not actually, surprisingly, not that bright. So shouldn't be bad.
Okay, is there something for me to center?
So no, I don't think so, but I have the finder chart for this, and if you want to put it in the object, sorry, in the MOSFIRE camera field of view, I'll go ahead and start taking exposures. Do you need me to?
Okay, we're good.
Okay, all right. So I'm going to take some test exposure here. We'll take a few. We'll take 3 test exposures because Uranus was a little bright. So, here we go. Boop. Apply. What was that noise? Okay, and go. Let's see. Oh, it's in quick dark mode. Ah, darn. Okay. Oh, never mind. It won't go yet. Yeah, don't worry. So I'm gonna put it in wideband. We'll wait for it to stop. We won't be rude to the telescope. So this will also help with the persistence. Even if it's in dark mode, it's gonna help. The more readouts you do, the quicker it gets rid of the persistence. So observation is in progress. Are you sure you want to move? I'm gonna click yes, because it's done anyways.
Exposure complete.
So it's now moving to the wideband filter. Yeah, it makes that whip noise when it is finished with an exposure. Let's see here. I'm going to go back to C scale here. All right, I don't see the burn-in of Uranus there, so I think we're good. I'm going to go zoom fit. Zoom fit to frame. Okay. Yeah, it looks pretty good. So maybe we'll just go ahead and start our science exposures then.
Yeah, there's no notable persistence.
Okay, Matthew, can you actually change the coads to, well, actually, hold on, let me see if I can do it first because they're,
I did.
okay, make sure repeats is set to 1. And yeah, click apply. So double check. 30 seconds eye time, 6 coads. Everything looks good there. Do you want to do the box 5? Or in that helps as well.
We're in wideband, right?
We are in wideband. Laura, you can see this, right?
Yep.
Okay, because earlier we weren't sharing screens, so I wasn't
Yeah, I can see it.
Wouldn't be easiest to see stuff. Okay. All right, so let me get our Finder chart up and going here so we can make sure that we are on the right track. Let me get things in the order that we're doing stuff. Priorities. Just like in surfing, asteroids have priorities. Does anyone here surf? Anyone in the audience?
Are there surfing priorities? What is that?
Yeah, it's like a surfing thing. I don't know.
Have one surfer in the audience for sure.
Yeah, so do they know what I'm sure they know what priorities are, right?
Yes, yes, he definitely knows what priorities are.
Okay.
Is it like the best surfer gets what looks like the better wave coming or something?
But better an actual surfer explain it than me. I'm a pseudo surfer.
Amen.
So.
Amen, you're up.
It's more just like depending on like where you're sitting in the lineup, the better surfers usually are going to go for the waves that start their break sooner, so they can get like a longer ride. So if you're shallower in the lineup, you don't cut them off because
Okay, yeah, sure. The direct. Okay, yeah, that makes sense. Thanks for explaining.
Yeah, thank you. Yeah, so we are prioritizing objects which are quote unquote the better surfers, and objects that are we think are anomalous in this population, that are very red, that may potentially contain organic material. So that's what this VV165 objects is, and then the other objects kind of follow it in priority. I'm going to double check my handy dandy spreadsheet here. Okay, we got VV165. Yeah, these all look good. All right, so let's see. I think we got our first image, if I'm not mistaken, or we're about to get our first image. So that's why I like having this long format, high axial ratio terminal right here, so I can see what frame we're on.
The humidity has really dropped.
Yeah, it's been one of those nights. It's a roller coaster.
Yeah.
So let's check the sky camera here. I don't see. It looks like it's clear. Complete. I mean, it's pretty clear. So to be thankful for that. Looks like we got some data here. Let's check the fields. Let's check the asterisms. So north is up and east to the left in this image. So let's see if I can put both on the screen at the same time.
Those three little ones on the left, the kind of triangle.
Mm-hmm.
Seems to be right there.
Yeah, you should see these three and these like sort of three. Is that
There's even a little galaxy kind of on the left edge of that top.
This one?
So the kind of left, the more on the left one. Yeah, exactly. See, there's a little galaxy right behind it. Yeah, exactly.
Yes. So for the audience, what we do every time we check point the telescope, we make sure that we're pointing the right part of the sky. So the way we do that is we look at a finder chart. So the left here are the actual camera image that we're getting from the telescope. Sorry, my connection's a little wonky here, so we gotta wait for it to. Yeah, this is good. This is good. Matthew, can you zoom out one more, just a little bit more?
Yeah.
Awesome. So the left image right here is the actual image from the telescope, and the right image right here, this is from the Pan-STARRS catalog.
Yeah,
so
that
Pan-STARRS
matches.
yes, it matches very well. So Pan-STARRS is a telescope of Mount Haleakala on Maui, and it did an all-sky survey where it has basically a really nice atlas of the sky, and it's very good image quality. So I've loaded up the Pan-STARRS catalog and pointed it into where our target asteroid is located. And we can see here that there's this group of stars in a galaxy on the left side, and there's this bright star, and there's this kind of this triangle looking thing on the right side. And if we look at our image here, we see that exact same thing. We see that there's this group of stars here, we see there's that galaxy, and then we see that bright star right here, and we see there's a few objects down here as well. So I'm going to go to this other window to make sure that we're checking on the exposure here. It looks like we're on frame 2, and looks like it's going pretty well. So let's see. Let's take the difference image and see what's going and see what happens.
Bryce, I want to ask you, how much thought have you given to the sampling mode we use? I've tried to find some documentation. It's kind of absent in terms of using the CDS correlated double sampling, the multiple correlated double sampling, or the up the RAM sample.
Okay, so one moment. I'll answer that in a second here. Let's check the difference image real quick.
Exposure complete.
Okay. So we got that, and then I'm going to press the tab key here, and that's going to take the difference between the two. We just want to make sure so it looks a lot different now because we're on we were on min-max mode, but now this is Z-scale. So now, yeah, so let's kind of get like before and after in the scale here. This shows the power of the telescope and what we were seeing before. I'm going to go to the before image here. Okay, here we go. I'm gonna have them both zoomed out. So this is the before image, before subtraction, and there's so much heat from the sky and from the instrument itself that you don't see nearly as many stars. But when you subtract the two images together, you remove all that contribution, and all the sources pop out. So that's why, you know, tons and tons and tons of stars, a lot more than you can see in the individual images. I'm gonna zoom full here, zoom the fit frame, and so we can see before and after right here. So I'm gonna go to the before, zoom the fit frame, zoom the fit frame here. This is the before, and this is after subtraction. So tons and tons and tons and tons of stars. I'm going to zoom in a little bit more now. Let's see if this works. If I say zoom to, is it going to zoom in out, or does it zoom in? It zooms in. Okay. All right. So maybe yeah, it's very non-intuitive there, but let's see if I do this, it zooms out. Yeah, so it's like that that quote from Space Odyssey, you know, it's full hours kind of thing. Like basically the telescope is so, yeah, the telescope is so sensitive that it sees stars that probably no one has ever seen before looking at this part of the sky. So if you look at the Pan-STARRS catalog, it's the number of stars you see from this image compared to the Pan-STARRS catalog is a lot higher in the Keck image. So that's just the way it is when you have a 10-meter telescope. You're a lot more sensitive. You can see a lot more fainter objects, and they're going to be in the catalogs because the catalogs didn't go as deep as the images that you're taking. So I need to answer Matthew's question, but the next thing that we try to do when we take the data is after we know that our dither pattern is correct, and we now know that we're differencing, we're on the correct field, we try to actually localize the source in the images just to make sure that we're getting good data and that we're getting good usable data.
You're about to get a new delta
performance.
come in.
Okay, great.
So let's try to
So
find
before,
it.
yeah. So yes. So let's see. We're going to look at the difference thing here. And so what I'm going to do is I'm going to go to the catalog here. So this is increments of 30 seconds. I'm sorry, 30 minutes. So this object doesn't move very quickly. It's moving about 0.04 arc seconds a minute. Our exposures, the total duty cycle is about 2.5 minutes. Sorry, 3.5 minutes. So we're really moving about maybe 1/10 of an arc second per exposure. So the target's moving very slowly. But even though it's moving really slowly, I like to try and get the approximate location as close as possible. Oh, sorry about that. That's CFHT there. It's another great telescope I like to use. So I'm going to go here. I'm going to go to pump this up to 80 so that I can get more positions, more precise positions than interpolating between a more fewer number of positions. So this is the predicted position that the object should have about now. So I'm going to look at it in the Pan-STARRS catalog, what its approximate location in the sky. And so there's an uncertainty in the position of a few arc seconds, but it's going to be in the vicinity of where there's kind of this blob of stars in this galaxy and this cluster of 4 here. I think I saw in one of the images that we took. So this is the newest delta, Matthew?
Yep.
Okay. So let's look for it in the finder chart here. So a similar thing. So we see in the Pan-STARRS catalog, I'm trying to get at the same scale. We have this group of 4 stars and galaxies right here, and then we have this object right here. It kind of makes kind of like this L shape. Can you zoom in again? Go back to where it was before.
Yes,
Thank you.
I think this one that little dot right there might be it. No,
it very well could be. It very well could be. So it's a little tricky because again, the Keck goes a lot deeper than the Pan-STARRS catalog. So there's some stars here that we don't see here.
Oh yeah.
So it can be kind of tricky because this thing goes so slowly that we could be confused. But just to kind of get an idea, you see that there's like this L shape right here, and there's this star right here. So let's identify that in these images right here. So we have this L shape right here, and then we have this star down here, which is probably this one.
Yeah, no, I think
we don't see these.
Object right here.
Yeah, I think it could be that one as well. But one thing that helps is you can measure it. So using the Vizier, using Aladdin, I can measure the distance. It's about 16 arc seconds, kind of south. We got new exposure. Kind of southeast of this star that was in that L asterism. I'm going to go make sure that we're still taking exposures here. So sorry to interrupt again. I'm going back and forth. I know it's very jumping around. So we took 1, 2, 3, 4. So this is our last exposure for wideband. So we're going to have to switch to H next. But so we have a couple of minutes to check this before we have to switch filters. Do you want to go to ruler? You go to ruler.
I tend to
there you go. You got it.
Line and then length arc seconds, and you can play around with that, Bryce.
Okay, so that's let's see
Probably
here.
not it.
So hold on, let's pull up the finder chart. Oops, that's wrong thing there. That's a sky map. So this is 16.45. I mean that source looks pretty bright, and you said that was how long? It's about 15 point. So looks
Yeah,
like
15.8 from
I mean, is that
Saturn.
it? I mean that could be it. So that could be it. You know, so you see this group of three objects right here, these three stars.
Yeah.
You don't really see them in the Pan-STARRS catalog either. They're very faint.
Yeah,
But
I thought that looked like a smudge, like a fingerprint on my laptop screen, but
yeah, and so there's this kind of other triangle looking thing right here that like puts up to it, and you can sort of
Okay.
see it. So that might very well be it. And
star.
that's pretty bright. That's a pretty good detection, I'd say. Signal noise of at least 10, it looks like, if that is our object.
Yeah,
Now,
let's see. The centroid has about a flock. The counts are 290. Yeah,
Mhm.
background's 200. That's pretty good signal.
Yeah. So yeah, I'm surprised because it's
Is
yeah,
this very
well, it's
red
just,
or
you know,
which category is this? Do you know?
this is a very red object, but
Yeah,
its predicted V magnitude is 23.7. So I mean that
so,
is a slam
so
dunk.
the very
detect.
reds
They
are going to
already
have a high.
red.
The very reds are going to go up in Y band more, so you should expect more flux.
Okay. Yeah. Okay, that makes sense. All right. Well, I think it's about time for us to change filters here.
10 more
Matthew,
seconds.
do you want to do that?
Yeah. Let's wait for this to finish.
Yeah, of
Another
course.
10 seconds and
So
yeah.
first thing first, when this is done, is click the button for imaging H so that you get the gears turning, and then we can fill out all the info in the exposure control.
Exposure complete.
All right, what is it?
So now you want to do 30. We want it to be 180 seconds each time, but in H band the maximum is 3
Yeah, it's
seconds.
the other one.
No, in H integration time is 3 seconds.
No, down to 3. Okay, wow.
Yeah. And then then you do 60 coads.
Yeah.
So we want product of the integrations and coads to be 180.
Yeah. You should point out that the clock time goes up, right? You can see the clock time here is 380 seconds. So
oh yeah. And that's because of the overheads.
all right, we are ready for box 5 again. Let's go.
All right, there you go. We're going to do the box 5 dither, the shuffle.
Yeah.
Now,
so okay.
Surprise. Yes.
Do you want to answer my question now about the CDS?
Yeah, sure. I was just going to say we are going to H band, but this instrument is surprisingly super sensitive in H band. So I'm thinking that if we saw it in Y band, we for sure should be able to see it in the H band.
Yeah.
Now, talking about the sampling. So I went over this when I visited Keck for the first time in Halloween of 2022. It's a very scary, very appropriate for Halloween because there was an earthquake, but which made things interesting. But one thing I discussed with Josh was the readouts, because usually I use what are called Fowler samples, where I take, you have a lot of read noise when you read out with an infrared instrument. So you want to do what is called Fowler sampling, where the amount of noise drops as the square root of the number of samples, Fowler samples that you take. So it does help to take additional readout samples. However, with this instrument, it's not so clear if it has an equivalent. So what we came to the conclusion was that the performance of the instrument was good enough that using the regular sampling mode with only 2 groups did not Basically the standard setup we have here is basically kind of the optimum. There is wiggle room for it and whatnot, and that's something we can investigate. But with my discussion with the instrument experts and astronomers over there at the Keck Observatory, was that this is kind of already an optimal configuration. But near-infrared cameras do work differently.
Sorry, I
Yes?
don't mean to jump in there. We are closing here at the Viz, and so I just want to thank you all so much for a
Thank you.
fantastic session. It was again an amazing adventure, and it's really fantastic to hear all of the discussion that you do during the observation and seeing all the roles that you're all playing, and also hearing Julie at the summit and people in the control room and all the Keck support staff. Thank you so much. I know that we still have Ava here, and so I'm happy to make one of you the host on the Zoom side so that Ava can continue with you all if you'd like.
Oh,
And then whenever you end the session, then whenever Ava's finished, then you can just end the session. Is that okay?
sure, sure thing. Ava, are you the student who is joining us? I'm sorry we didn't get to introduce each other. We were really going setting up the telescope, but
It's been good.
are you there at Keck? Is Ava with you, Jamaica, or is she at Keck HQ?
I'm not sure. I think Josh said that this was a student from Kauai joining. Is
Okay.
Oh.
Oh.
Unmute yourself, or you can type in the chat, Ava.
She may have stepped away from the computer for a minute or something.
So what I'll do is, Laura May, can I make you the host?
Better, I'm not going to stay for too long, so probably better to make
Bryce.
Yeah.
Make it Bryce. Okay, so I'll make Bryce the host, and then just check in with her in a few minutes, and if she's not there, then you can go ahead, please, and end the session. She may have stepped.
Yeah, and we can move to the.
This has been absolutely amazing, you all. I'm looking forward to our February sessions with y'all. Thank you so much.
Thank you, Jamaica.
Thank you for organizing these.
Thank you. Aloha.
Aloha.
Aloha.